Class, welcome to the beginning of 7.5 Proportions in Triangles Notes. Here's our first question, similar or not? Is triangle QRS similar to triangle QXY? Here we have it right here, QRS, triangle QXY here. Why don't you give it a second to think about it? This will be better in class. How about you pause the video, think about it. If you pause the video and you can prove it, you get bonus points. I'll just jump right to the case then. The triangle here, QRS, and the triangle QXY at the top here cannot be shown to be similar. But if you look at the one below, this QRS and this QXY are similar because this diagram has this extra little bit of information here. These arrows, which of course mean that RS and XY are parallel, which means that not only do both triangles share that angle, but this angle and that angle are congruent because they're corresponding angles for these parallel lines cut by a transversal. Corresponding angles are congruent. That also means that these angles are also congruent because they're also corresponding angles. We don't need to know that because by AA, angle, triangle QRS is similar to triangle, same technical difficulties at home, QXY. Okay, not in this case. This one's not enough information. In this case, because the lines are parallel, that's the key right here. These lines are parallel. That makes these angles congruent because they're corresponding angles for parallel lines cut by a transversal. So now that we know that these two triangles, the small one and the bigger one, are congruent, they're not congruent, sorry, similar, we can write the extended proportion of corresponding sides. We'll start with the first one, RS over XY. RS is the smaller side, the side of the smaller triangle, XY is for the bigger one, equals, now here's where a lot of people are going to make a mistake. It's QR, that's the side of the small one, but the side of the big one is the whole QX. A lot of people make the mistake of saying RX, but that's not true because RX is just part of the whole side of the triangle. QX is actually the whole side. And that makes the third part of this proportion QS over QY. Not SY, but QY. So now let's use that information to figure out what W is in this triangle here. It's the same triangle, but now I've put some numbers in there. So set up a proportion like the one written above and solve it. So let's use this portion of it, QR over QX equals QS over QY. If I just substitute in, QR is 3, QX isn't 2, QX is this whole thing, which is 5, equals, here QS is 6, and the whole QY is not W, it's 6 plus W. The whole thing. The whole side is this part plus that part, 6 plus W. Now we can cross multiply and solve for W. Notice, like we talked about in class, you can't cancel out these 6's because this is 6 plus W. If it was 6 times W, you would be able to cancel them out, but not when they're added together. So let's cross multiply. We get 3 times the quantity, in parentheses 6 plus W, equals 5 times 6. We distribute this 3 now. We get 18 plus 3W equals 30. Subtract the 12 from both sides. We end up with 3W equals 18. And then we divide by 3 on both sides. We end up with W equals 6. And that's what we were looking for. Find W. We got it. We got it. Okay, what do you notice now about the ratios of XR, which is just this part here, XR to RQ, so let's see, that's 2 to 3, and YS to SQ. YS is W, which is 6. 6, that doesn't make any sense at all. Where did I make a mistake? This can't be the same thing as that. 5, 30, 30, 18 plus 3W. Because, there it is. I said 18 and I subtracted 12 because I was thinking that's the answer. So actually, it's subtract 18 from both sides. Good job, anybody who caught that. Bonus points if you can prove it. This is a 12, which makes W actually 4, not 6. Thank you guys for finding my mistakes. I know you were yelling at the screen for a little bit. That's good teaching when I get you to think about it and yell at the screen. Alright, so here we are. Instead of 6, it's 4. 4 over, and then QS or SQ is 6. And what do we notice about those two ratios? They're equal. 2/3 and 4/6, those are equal ratios. So some of you, I bet, when we saw this problem up here, originally wanted to do 3 over 2 equals 6 over W. That's not the ratio of the sides. The whole side here is 6 plus W. The whole side here is 3 plus 2. But it turns out that even though that's not the whole side, the parts of the sides are proportional. So even though it's not the whole side, the little pieces of the side are proportional. And that's what we call the side splitter theorem. One of the cooler names in geometry, the side splitter theorem. Basically, we've got a side here and another side over here, and it's being split by this line right there. So that's why we call it the side splitter theorem. So the side splitter theorem is if we have a triangle and a line is drawn parallel to one of the sides of the triangle. So I'll say if a line is drawn, line segment, I know you love when I add those little things. If a line segment is drawn parallel to one side of a triangle, then it splits the sides up, splits the other two sides up into proportional segments. It splits the other two sides into proportional segments. Okay, the line has to be parallel. So in this case, RS is drawn and it's parallel to the side XY, and it splits these sides up into two sets of proportional sides. So basically in this one, we end up with QR over XR, or RX, equals QS over YS, or SY. That's what the side splitter theorem is. It's something that a bunch of you have already done intuitively, or wanted to do intuitively, but now I'm telling you, you're able to do it. It's a theorem, which means, guess what? Turn the page. We can prove it. I'm not going to ask you to prove it, but I am going to show you informally how you can prove this. You don't have to know this, so if you want to skip ahead, you can, but by the time you figure out where the next notes start, you probably just wasted the same amount of time as listening to me right now. So, we know that triangle QRS is going to be similar to triangle QXY by AA. I already said that in the first page. That means that QR over QX equals QS over QY. And then I'm going to break QX into its two parts, that part and that part. So that's actually QR over QR plus XR. Same thing with QS, or rather QY is QS plus SY. little thing in math, we can flip both of these. We can write the reciprocal of both fractions. It's basically like cross multiplying and then dividing both of them again. So we have QR plus XR over QR equals QS plus SY over QS. Another neat trick in math, when you have fractions where they're added on the top, you can split them up. And this becomes QR over QR plus XR over QR equals QS over QS plus SY over QS. Now QR over QR, those are the same things. That's actually 1. Anything divided by itself is 1 plus XR over QR. Do you see where I'm going with this? QS over QS is still 1 also, plus SY over QS. Subtract the 1 on both sides, and you end up with XR over QR equals SY over QS, which is the side splitter theorem, saying that these sides, or rather the split sides, all 4 of those are proportional. Alright, hope you enjoyed that proof. Now let's use the side splitter theorem. What's the value of x in the diagram at the right? Alright, we've got our 2 triangles, we've got parallel lines here, which means we can apply the side splitter theorem. So we can say 12 over x plus 1 equals 9 over x. By the way, again, if you didn't know what the side splitter theorem was, you could just do 12 over 12 plus x plus 1 equals 9 over 9 plus x. That's totally valid, and you'll get the same answer, but it's just more work. So using the side splitter theorem, we have this. We cross multiply, we get 12x equals 9 times the quantity x plus 1, which is 9x plus 9. Don't forget to distribute to both of them. Subtract 9x from both sides. We end up with 3x equals 9 divided by 3. Ladies and gentlemen, for 3, x is 3. That's the answer. And that's what we're trying to find. Just checking it over here, x is 3, 3 plus 1 is 4, and x is 3 over here. 12 compared to 4, 9 compared to 3, well, these numbers are both 3 times these numbers. So it checks out. What's the value of a in the diagram at the right? This one, you're going to have to do yourself. Do it just like I just did that other one. That's up to you. That's part of the notes. You got to do it yourself. Try this. Alright, then we have a corollary to the side splitter theorem. Corollary, or for Canadians, corollary. The corollary is more bonus points if you remembered and can prove it. A corollary is a little extra piece to a theorem that's more specific usually. So we take this theorem and then we take it one step further and we get the corollary. So for the corollary of the side splitter theorem, basically have if 3 parallel lines intersect 2 transversals, then the segments intersected by the lines are proportional. If you were to extend these lines out, you would see a nice triangle. And in fact, here I'll do it in blue. This triangle here and here, that parallel line, that's the triangles that we've just been doing. Those are the side splitter theorems. Same thing, you can draw it for this bigger triangle, going down to CY there. And if you do that, you can see that any of these segments, any of these pieces of the lines are going to be proportional. So basically, the corollary to the side splitter theorem is if you take 3 parallel lines, if you have parallel lines like that, and they intersect 2 other lines like that, then all the pieces in there, like this part and this part and this part and this part, are all proportional. So for that diagram, we have AB over BC equals WX over XY. They're all proportional. That's the corollary to the side splitter theorem. let's turn the page. Last thing that I'm going to do, 3 campsites are shown in the diagram. What is the length of site A along the river? Looking at the diagram, I can see that these lines are all parallel. So the corollary to the side splitter theorem is 3 or more lines that are parallel, intersecting 2 other lines. That means that all these segments are proportional. So what am I trying to find? The length of site A along the river. I'm going to call that x. Here's x. So I can set up a proportion. There are a bunch of different proportions you can write. I'm going to write x over 8. So those are the 2 segments on this side of it, is equal to 9. 9 corresponds with the x. So 9 over, and then this part, 7.2, corresponds with the 8. And then I'll solve that. But of course there are a bunch of other proportions you could do, like you could have also said x over 9 equals 8 over 7.2. Oops. 8 over 7.2. That's another way of looking at it, and that kind of is more obvious maybe because of the diagram set up like this. But anyway, we solve this by cross multiplying. 7.2x equals 8 times 9, which is 72. Oh, that's interesting because 72 divided by 7.2 is, of course, going to lead us to become x equals 10. All right. Just checking my work here. 10 over 8, 9 over 7.2. I think that makes sense. Yeah. Okay. X is 10. So what I want you to do is to try this. Find site C. Please do this part. And then after that, you're done. So I'm going to stop the video. Stop the video. How do I stop it?